Hello everyone, and welcome to this short video about how to use packages in Java. So a short introduction first. You are, I'm sure, all familiar with folders. Whenever you have a file or program or whatever on your computer, you probably structure that into folders. So you have some folders, and inside a folder, for example division A, you can have subfolders, and these folders can also have subfolders. For example, I have my own folder structure. I keep everything organized. I try to. So I have a folder for me, and I have a bunch of stuff. And for example, I have a folder about all the courses, and I can click on SDJ2, and inside SDJ2 I have a folder for each semester that I have taught SDJ2. I can go in here and there's some stuff. Apparently I need to do something, right? So all my files and programs and whatever is organized into folders, so I know where everything is, and I have a structure here, so I know where to look for stuff. And it's sort of the same thing that we want to achieve using the folders or the packages in Java. It's the same principle. So whenever you write code, you create classes, you should really think about creating folders and organizing your code so it makes sense and you have a good structure of your code. When you're doing your semester project, it will definitely help you if you organize your code so you know where to find different functionality or different classes, and you know where to put stuff. That will really help you. Okay, so in this example here, this is Eclipse. When I create a new project, I've called it package Intellij here, you automatically get a source folder, and inside the source folder I have created a package called export, marked with this icon here, and inside the export package there is a data exporter class, right? I also have imports and maintenance with classes inside. Okay, so let's take a look at how this works. So I open up Eclipse here. I have a project called packages. I have a source folder that came automatically, and I can right click the source folder and I can create a new package, and I will call this package 1. Okay, here we go. I can then, inside package 1, I can create a class. I will call it class in package 1. Not very interesting, but you will see that I have a class here, and it has a package definition at the very top stating that it is located in package 1. So my class in package 1 is inside the package 1 package. I hope that makes sense. Now I can also create a sub-package. If I create a package again, you will see that initially here the name is package 1, and then I will put dot and I will call it package inside. All right, and you will see that I get a new package called package 1 dot package inside. I can create a class in this one as well, and I will call it the pack class inside package. Yeah, and we will see that the package name is package 1 dot package inside, and then the actual class name down here. Now if I create a few more packages, I call this other package, and maybe the last package, I don't know, here we go. You will notice that the empty packages are with a white icon, and the non-empty package are with the brown icon here. Now you will also see that it sort of looks like they are all at the same level in the hierarchy here, even though package inside is actually inside package 1. So if you want to change this view, I personally find it a bit confusing because it doesn't really match the usual folder structure that I'm using in Windows. So you can go to this tiny arrow up here in your can I drag this a little bit? Right, you have the Package Explorer tab. There's a tiny arrow up here. I'll just this one here. I will go to package presentation, and by default I believe Eclipse is using flat, which means that everything seems to be at the same level. I can click hierarchical, and you will see that I sort of lost a package, and if I expand this one, I have a package inside. So this is more along the lines of what you see in Windows, right? And I can expand this, and I can see that I have packages all over the place here. Okay, so this is a way to keep everything structured, and you can put classes in on the packages depending on where they belong. Okay, so next part here is that sometimes you have a class. This is a class here in one package, and this class may be using the array list. You will see that it's called Java util array list, and it is also extending, right, the class called super here in package 1, and here we have a class called using that uses the super class here in package 3. So whenever you have one class that somehow should know about another class in another package, you have to do the import. Now usually Eclipse will just suggest something to you, and I'm sure you have just done the quick fix, but let's try to set this up and let's go through what's going on here. So I need 3 packages, 1, 2, and 3. Let me just delete these 3 and start over. I will create package 1. I will create package 2, and I will create package 3. Okay, I need in package 1 a class called super. New class, I call it super. There we go. We can see that it is inside package 1. In package 2 I need a sub. I will create a sub. Here we go, class called sub. And according to my diagram, it extends the super. So I can use this here. I use the extends keyword, super. And now Eclipse complains, here let's mouse over, we say that Eclipse says super cannot be resolved to type. So basically Eclipse is saying, I don't know what super is, right? There are some quick fixes available. I can import super located in package 1. So this is super in package 1, and this is actually what we want to do. So I mouse over, I get this one, or I can click out here, and that should also give me the quick fix. And I click the super, double click, and you will see up here that I am now importing the class called super located in package 1, and Eclipse is now happy. All right, everything compiles and looks good. Okay, so I'm importing something from another class. I also have this case down here that the sub is using a Java util array list. So array list is something that we have from Java, and I will just create a private field, array list, and maybe it contains strings, doesn't really matter, I call list. And again you will see that Eclipse is complaining. I can mouse over and I get the same error. This class doesn't really know what an array list is. So I can import array list from java.util, and this is what we want to do, Java util array list. And now the array list is found and can be used. Let me just, yep, there we go. If I want to, so this is in my subclass, so I have to import anything that is outside of the same package. So if I'm using something, a class that is outside package 2, I have to import it. But if I'm using something that is inside package 2, I will call this other sub, right? And doesn't really do anything, but back in the sub here I defined a private other sub OS, and you will see that it can find it automatically because the 2 classes here are located in the same package. Okay, so we go back to the example. Let's look. I also have a class in package 3 called using, which will more or less be the same as the array list case. I call it using. I can, for example, in my constructor, let me create a constructor, public using, and here I create a, what was it? This one is using the super. Let's go back again. Here we go. Super s equal new super. Okay, I'm trying to instantiate a new instance of the class called super, and we will see again the red line, Eclipse is complaining. I can mouse over, and I can do the same quick fix about importing super from package 1, which is the one I want to use, right? So same case, I have now imported the class. My class called using now knows about the package.super. Okay, let's take a look at the next part here. So we know about the import statement, right? I can import a specific class located in a specific package, but I can also say that I want everything in a package. So in this package 1, for example, I just have the class called super, but if there were multiple classes in here, I could import all of them with just this one statement here, package.star, meaning that I want everything in the package 1. So if I take my example in Eclipse again, for example, here in package 2, I have, let me just create another class, last class. Okay, so in using, let's pick this one again. It knows about super. That's probably okay. But let's also make it know about the classes in package 2. So I want a private last class, LC. I want a private other sub OS and a private sub S. Right, and it doesn't know, my class here doesn't know about any of them. I get the same mistake. There are some quick fixes available. I can import this. I can import this one. And I can import this one. Here we go. And you will see that I am now importing 3 different classes, which are all located in the package 2. So what I can do instead of having multiple import statements here, if I remove these again, right? It now complains, obviously. I will just import the first one. And then instead of a specific class, I will import star. And here we go. I'm saved. And it now knows about everything located in package 2, which is, the classes last class, other sub, and sub. So this is another way of importing stuff. But usually I personally prefer to import whatever I specifically need, right? So I would import these specifically instead of just using the star, because the star just basically imports everything, the whole world in that package, and maybe you don't always use that or need that. So you might be importing stuff that you're not going to use, and then why import it? Right. So that was a slightly different case, but you can then use the import with a specific class, or you can use the star here to just indicate that you want to import whatever. Okay, so yeah. This one. I mentioned that whenever you write a class, you create a class, you should create a package for it. If you use the default package, sometimes you will see some strange behavior. I don't really have a good example, but just keep everything sorted into packages. It's good practice, and that's the way we do it. Okay, so here's another point that confuses people sometimes. The name of a class is actually its entire package path. Right, so this one, I have an example here about a Sudoku solver. So the class name is Sudoku solver, but this is sort of like its first name, or whatever you want to call it. So handin2.sudoku.sudoku with GUI.sudoku solver, that's actually the class name here. And maybe I can show this in Eclipse somehow. If I mouse over, then I can see the class called using. It's actually called package3.using. Okay. So I think that was more or less all about packages. Now personally, well, I showed you all in Eclipse because that's what you learn on first semester, but personally I prefer to use what is called IntelliJ. It's I find it slightly more clever, and hopefully some of you will also be converted to this religion. So I can just wanted to show you the same idea in IntelliJ. I also have a sort of a similar to a project folder. There's a source folder, and this is where you would put the code. I can right click it, I can create new and create package, and I will just call this package 1. Okay, and you will see that it's located beneath. I can create a class inside here, class in package 1, and we can see that the class is located inside the package. I can also create another sub package. Package 2, and you will see that it is now located inside. Right, so package 2 is inside package 1. I can also here create a class in package 2. And if I want this to use the class in package 1, like this, private class in package 1, now you will see that IntelliJ is slightly more intelligent, so it's already trying to suggest or predict what I want. But if I just continue typing here, package 1, CIP, right, it will complain. In the same way, it's marked red. In Eclipse, it was red underline, and I can do the same thing. There's a quick fix, and I can just import class, right? And it will import the class for me. So now I have access to the class. Okay, so that's all for packages. I expect that you use this in well, from now and until forever, basically. And just one last thing here, we might as well, because then in your semester project, let's call this SEP2, I suggest that you organize your code into packages. And because you're doing a client-server system, then you need to separate the code. So you need to know what belongs to the server and what belongs to the client. And you're also going to need some classes that are known by both the server and the client. So my usual suggestion is to create a client package. And I can create another package. I don't want it located inside the client, but just in SEP2. So I will remove the client and I will call it server. So I have a client and a server package, and I will have something called shared. I want a package called shared inside the SEP2. So this is my setup. Here I can create my client class. Here I can create a server class. And this one, the shared, is usually for data classes, data containers that you want both the server and the client to know about. So this one might be a personal class. I don't know. But, so I have that in the shared. So this is an approach to keep your semester project organized. And now I think that is all I want from this video. Thanks for watching.